Today we define the Moore-Penrose pseudoinverse and prove that it exists and is unique, because apparently ordinary inverses were too restrictive, and mathematics decided to get more flexible without becoming completely feral. Many matrices are not square, and even square ones may not be invertible, so we want a substitute for the inverse. Not a perfect replacement, obviously, because life is disappointing, but something canonical and useful. Here is the definition. A matrix X is called the Moore-Penrose pseudoinverse of A if it satisfies these four equations. The first two say X behaves like an inverse as far as possible. The last two say AX and XA are self-adjoint. If such an X exists, we denote it by A+. As a sanity check, if A is actually invertible, then A+ is just the usual inverse. So we are not inventing a new object only to rediscover the old one wearing a fake mustache. To prove existence, take the singular value decomposition of A. Then define sigma plus by taking reciprocals of the non-zero singular values, leaving zero singular values alone, and flipping the rectangular shape. Finally define A plus to be V sigma plus U adjoint. This is the candidate. SVD saves the day again. Shocking. Now verify the four equations. The first two reduce to sigma sigma plus sigma equals sigma, and sigma plus sigma sigma plus equals sigma plus. The last two reduce to the fact that sigma sigma plus and sigma plus sigma are diagonal projections, hence self-adjoint. So the candidate really is a Moore-Penrose pseudoinverse. Existence is done. For uniqueness, suppose X is any Moore-Penrose pseudoinverse of A, conjugate by the same unitary matrices from the singular value decomposition, and define Y equals V adjoint XU, then X equals VYU adjoint, and the four Moore-Penrose equations for X become exactly the same four equations for Y and sigma. So it is enough to prove uniqueness for the diagonal matrix sigma. Now solve the diagonal case. Since sigma is diagonal, the self-adjoint conditions force Y to line up with the same singular basis. Then the equation sigma Y sigma equals sigma forces the first R diagonal entries of Y to be 1 over sigma I. The equation Y sigma Y equals Y kills everything else. So Y must equal sigma plus. Therefore X must equal V sigma plus U adjoint. That proves uniqueness. So the story is clean. The Moore-Penrose pseudoinverse is defined by four equations. It always exists, and it is unique. And once again, the singular value decomposition does nearly all the serious work, while the rest of us stand nearby pretending we contributed equally.